I learned that from Emily. I didn't realize it either. Oh, I do know that. It's you click the display on off thing in the upper right hand corner.
Oh, okay.
And then it takes you into a thing, but you got to press the little power button on it. You got to do it twice until that beeps.
Okay. Because yesterday Dr. Lee said to stand on the table to get it on.
Oh. Yeah, no, that's how you do it. But you got to make sure you hit the button 2 times on the screen, otherwise it doesn't trigger it. Okay, recording. Oh. We have homework?
We did.
Was it hard?
It was not easy.
Oh.
It was the curl test thing.
Am I going to have to use a text editor to do it? No, she's wondering if I watch YouTube videos on how to use VS Code. I struggle with this newfangled technology. All right. Well, I mean, I prefer just to use like VI from the command line, which is better.
Better is subjective.
All right. This is us, right?
Is it
All right.
recording by chance?
Yeah. I hit it, right?
Yeah.
Okay. All right, everybody online can hear me and see the screen and all that jazz. All right, so last time we wrote, we walked through this thing called curl test. We looked at how curl works on Linux. It's a external program that's been kind of an industry standard, been around for a long time. It allows you to effectively download the contents of a URL from the internet. So it kind of does the same thing as a web browser does, but it does it as a single program call. And we looked at one of the features of using C and C++ on a Unix platform is there's plenty of libraries that allow you to access these external programs. So we brought in curl.h into our application, and we had to install libcurldev as well as curl on the on your machine. So I put up the apt get install command on Slack. I think I put something up there that installs all 3 things. So if there's something you missed, it'll just install the one that you're missing, but that command should get them all, which will then make this line not screen. The other thing that people struggled with is making sure that when you compile, you link curl. So you do G++, the thing, -L curl. That way you bring that curl library in so it knows about this and the stuff that you're going to write in that. All right. I think I even put that in the assignment, right? Like, hey, here's some stuff to remember, but nobody reads the assignments. It's a thing. Like you wouldn't have to type it in by hand? Yeah, so as an example, and you can write this if you want in your, I don't know, stupid text editor. Why isn't this, we'll just start a new one. But another nice thing you can do, and you could do this in Windows too, but it's pretty common to do something like this in Linux. So I'll just go into this folder. What was it, Hearthstone thing? So similar to what we did here with this push thing to automatically push, I can go ahead and just create a folder, so or create a file. So in this case, we were doing G++ curl test -L curl, that thing, and that gives us then our command line ./out or a./a.out, and then it was asking us for the URL, right? So we can give it like I saw your post. Is it yahoo.com?
Yeah, what the hell is this? scares me so much.
Well, I just got redirect.
Oh, do you need HTTPS?
Well, the reason you got this is HTTPS is encrypted.
Okay. Well, I thought I put in Google about HTTPS.
Right, but that so the difference is they're sending it as an encrypted thing from Yahoo. With Google, they must redirect you to a public site, but you establish the initial connection through a secure site.
Okay.
So they're redirecting you there.
So does that mean if you put in like a link to like your bank account or something, it would do something like this?
Presumably, I mean, you probably wouldn't be authenticated, so you would just get the, bank's main web page. But I see what you mean. If you had copied the link, it would probably bounce you back to the login page or something. But that's what I'm presuming is going on here with this.
This definitely made me feel like I wrote something.
No. Well, my guess is your computer got erased. So.
That would be good thing it's a virtual machine.
Yeah. So that was the command to compile it. This guy right here. So what I can go ahead and do is I'll copy this, and actually the better way of doing this, I'll show you it in a second. Actually, well, I say better. The more traditional way of doing this for larger projects is something called a makefile, which I'll show you that example in a second. But this is kind of like the quick, dirty way of just pulling this off. So to copy this, I'm pressing Shift Control C. You could also just go up to Edit and hit copy. Then I'm going to open up a file. So you can do this in VS Code if you want, but I'm just going to VI compile. It's called compile. And I will paste that line in there. And then when I do ls, you notice this file is a different color than this file. So you have to make it executable in order to run this. So we do that with this change mode command. So now I have that. So I can do just /compile and it'll do that thing. So as long as you keep the thing in compile up to date with what you need to build, or if you need to build multiple files, all that stuff. Now, an alternative to that, just to give you an idea, this is from the 450 class where we're writing device drivers. Here, we just look at the first character driver, this guy. So lots of stuff in here, right? So one of the things we have is this thing called a makefile. So inside the makefile, it says, hey, here's your object files. This is still pretty similar, but for make, we are having to include a certain library that's in there. So a bunch of stuff that isn't necessarily convenient just to type out at the command line, right? So we have a make all and a make clean. Make clean will clean up the extra stuff. So right now you see a bunch of crap in here. If I do make clean, it cleans that up some, gets rid of a lot of those things. If I do a make or a make all, it does the building, and now I have that stuff back. Then if I want to read from the thing, I put some stuff. So this is something similar to what we just did, a command that you just put in there. So if I want to read from this character driver /read, oh, I haven't created my, I need to install the driver first, but you get it. Each one of those has stuff in it that is the related to what we have to do. We would call that probably the more formal old school way of doing it with makefiles, but you do have to follow kind of a specific syntax, and you'd maybe transition over to makefiles if you were working with a fairly large project where you kept adding new stuff into it. That doesn't mean that necessarily what we're doing right now wouldn't be conducive for that. But I would say let's just keep it simple. Sure.
So green is executable files. What is green?
Well, red is a link. So if I go back into was it my first something or other? If I do an ls-la, see this guy, it actually links to another place on the computer.
Okay.
And these are just color codes for Ubuntu's terminal application. There's no guarantee he's going to do any sort of pretty colors, just normally. All right. So now we have our compile thing. So the homework for today was to basically take this logic from curl test. Is that what this guy is? I need to hide this again. Let me make sure everybody's in it. This logic that we saw work yesterday and suck it into an object so that whenever we want to read from a URL, we can just create an instance of that object with the URL we want to read from and then say read or something like that. I think in the notes, didn't I give like an example? Yeah, so you would create a URL and then you would say get contents, something like that, which would read from it. All right, go back here. So we're going to create a couple of things here. We're going to create a header file. So similar to what we did for card CPP. In fact, I'm just going to steal this as just a starter template. And I'm going to create a new file, and we're going to call this guy url.hpp. And we're going to be creating a URL called, or a class called URL. And it's going to have a string. Let's call this guy the URL. And we'll have our constructor for this guy, and he'll take in a URL that we're going to be opening. And then what did I call the function? Get contents. So we'll have a get contents function that ultimately is going to return a string like that. All right, so we're going to say that's what our class URL is going to look like. So this is our header file for that. Now we're going to go ahead and we're going to write our .cpp file for this guy. So this will be called url.cpp. And I'm going to include url.hpp. And let me just steal some stuff from and then I'm going to steal my functions from here. So we're going to remember the header file is there to prototype the things we will be building. And here the implementation is where we actually build them. So we link back to it by doing something like this. So in our constructor for URL, we're going to set this, the URL is equal to the URL that was passed in. Then get contents. Now we can go two different approaches here. One approach we can say, well, we can just put all of the logic for actually grabbing the stuff from the site inside of the constructor. Or we can say, let's put that inside of get contents. So every single time we call get contents, we get the current version of the site. Presumably, let's just say that, you know, we're writing an application that gives us up-to-date Packer scores or something like that. And so we happen to be reading from a certain website that has the scores on it. And we're going to go through and find where the score is in the HTML and pull it out. Well, every single time, you know, maybe we have it on some sort of heartbeat where, you know, every 15 seconds it hits the URL again, downloads the HTML, goes and finds the score and puts it out there. We want to get a fresh version of the site each time. You could have decided on the homework, which made more sense. We'll go ahead and inside of get contents, we'll have it establish all that stuff for actually making the connection and getting the stuff. So let me open up curl test here because we're going to be stealing logic from this guy. So we're going to need our curl.h. And we'll put this in URL. Okay, now remember, now I would probably go ahead and in the private section have our string called contents. That way we can access it from these different things. But one thing we're going to want to do, so I'll go ahead and I'll put that, we'll put that up here. So this is accessible anywhere inside the program. But one thing I'll do is whenever I get contents, I'm going to go ahead and empty it back out first. Presumably because if I'm calling get contents for the second or the third or the fourth time, I want to start with a fresh string that I'm ultimately going to be displaying. I don't want to just keep tacking on the web page on top of the web page on top of the web page. All right, so whenever I call get contents, the first thing I'll do is I'll set that global variable equal to the empty string in preparation for reading some stuff in. So then we have our handle data thing. Nothing's going to change here. This guy's already working with contents. We walked through all this code last time. So we'll toss that guy in here. So there's our handle data. Now you could have prototyped this inside of, in fact, you probably should have. So if we go here inside of our header file, since it's a function that we will be writing, we probably should have prototyped that in here.
Why do you not?
Well, kind of for the same reason as we mentioned last time. The whole purpose of prototyping is for historical one-pass compilers that make sure it gets all the symbols read in before it hits them. That way, if you have a function that's reliant on another function and they're reliant on each other, you don't have this problem where I can't define these in any order where it doesn't break. In this particular case, we only have one thing that happens to use handle data. So since handle data, I'm defining it here at the top. If I put it at the very bottom, it would break. But since I'm defining it here at the top, the thing that actually uses it is this curl command down here, and it's already seen it because it went through there. But the appropriate thing for us to do would be to go ahead and define it in the header file like this and say, we are going to write one of these guys. And we actually might need to do something a little funky with this. In fact, since it's a C library, well, this is going to be interesting. So let's go back in here. So now we're going to go ahead and write this appropriately. We should write this guy as URL : like that. It's part of the class. Now, what we might need to do, we'll have to see how the connection ends up working, but we might go in here, we might actually move this outside of the class and prototype it outside of the class, which would mean that we're no longer saying this guy belongs to the class. It's just a function that needs to get called, and I needed to prototype it somewhere, or I should prototype it somewhere. So really the cleanest answer to your question is always prototype all your functions, regardless of whether you would have had to or not. It's never going to be wrong to put your function headers in a header file so that the symbols get read in when you compile, and then you just have them, even if you could have gotten away without doing it in specific circumstances, something like that. Okay. You know what? In fact, I'm going to say that this is more correct for this. Specifically, this handle data function is really not part of my URL object. It's used by my URL object, but it's not really part of it. I might change my mind on that, but let's truck with that for right now. So since I put it outside of the class here, I would not mention it as being a member of that class. I would just define it up here. Okay, so I'm not actually defining it as part of the URL class. I'm just defining it as, here's a function that you might need later. Okay. So go back into curl test here. So this is the magic that went and read it from the URL. Presumably, we're not reading it in as an argument here because we're actually building this. I'm actually going to steal this. Yeah, just steal all that code, and we'll work with it over in here. So inside of get contents, we're going to go ahead and we'll create our pointer to our curl object. Then we're going to say, hey, as long as this guy worked out okay, we're good to go. All right. Then we're passing that to our set options. So we're setting the URL, but now the new URL is no longer stored in argv. The URL is actually stored in the URL. So this, the URL, right? That's what I passed into the constructor. So for this particular instance of URL, the URL that we should be opening is the value stored inside of this URL. All right. Also, here's our handle data. So this is where I said things get a little sketch. So the way it's written here, all variables and the functions work the same way. Even in Java, the same thing's true, but Java makes a much cleaner delineation between what's a variable and what's a function. But the reality is anything with a name is a variable. So a function like handle data here is a variable name that has a value. The value type of this variable name, this is something you learn about in the programming language theory class, is something called a lambda, which is an unnamed procedure, okay? So the value of handle data, which I wrote up here, is all of this crap. That's its value. And what kind of value is this? It's a function. Takes some parameters, does some stuff, but it doesn't have a name until I associate it with a name that is the variable name. Name value pair. Name is handle data. The value is a lambda expression. That's the type for it. So this really isn't anything new. It's just giving you an explanation under the hood of what it's asking me for here is the name of the function I want it to call. I could have embedded this function inside of this particular object, in which case I would have said, I could have said this arrow handle data. But I didn't say this arrow handle data, but that doesn't mean it doesn't first check in this function for that. This has to do with how scope is resolved. So C++ is going to say, you've passed me a variable name. Let's go find that value. First thing it's going to do is it's going to look around on the ground right around it, right here inside of get contents. It's going to say, nope, didn't find them there. Then it's going to bounce up another level and see, did I find this as part of the URL class? Nope, didn't find it there. Then it's going to look at the more global level and say, here we go. He was prototyped inside of URL HPP. Which I wrote right here, not as part of the URL class. But we could have put it in the URL class. I just didn't. So it's going to find it in that global space. All right, but the way it got there is by checking the other places first. So maybe from a performance perspective, it would have made the most sense to put it inside of the URL object so that I didn't have to tell it I didn't have to rely on it to go and find it. I didn't send it on a wild goose chase. Instead, I just said, look, the method you're looking for is this arrow handle, whatever it was called, lives in the class. But let's leave it like this for right now because I'm interested in the behavior between these two libraries. All right, so we'll go back down in here. So get contents is going to do all this stuff, call that handle data function. Well, right now it's associating that handle data function. Then we actually call it. This performs the let's go do the magic action. All right, then we clean it up. Now this was just writing it out to the screen and stuff like that. We don't actually have to do this if statement thing, but you know, we can say if the result, this guy was equal to 0, if everything worked out okay, we can go ahead and return contents, right? Because that's where my string was collected. That's where the data was collected. All this other stuff we did here was just, you know, to print it out to the screen. Else, we can do a, am I not using standard namespace? Oh, did I not include IOStream? Oh, thank you. Yeah, input output stream. So IOStream is the new version to standard IO. So yeah, IOStream is where C out lives. It's where C in lives. I don't think we've looked at C in yet, but it's Java's scanner. It's how you read stuff in. And it's where C error lives, which is typically most operating systems have 2 output streams, standard output and standard error. Windows does, DOS does, Mac does, Linux does. So they're just saying, hey, if you want to have an error message, why not write it out to C error? Why do you think there are 2 different output streams, a standard output stream and a error output stream? What's the advantage of having 2? Is it just a 2 is better than 1 type thing? Or is there an example in an operating system where you might be only interested in errors? Something goes wrong in an operating system, where do we usually put that stuff? Well, you might see it on the screen, but we also have log files, right? So we might go and look at log files and see kind of what things have happened. Well, we probably don't want these log files to have everything that's ever printed out to your screen. We probably only want it to have the error stuff in it. Does that make some sense? That's why we can delineate between, hey, this is stuff for the consumer's eyes. The user wants to see the dumps to the screen of whatever. That's great. I'm not going to remember that somewhere. That's the normal computers working, whatever. We don't want to capture everything that's ever shown up on the screen inside of some log file. But errors, we might care about errors. So as a programmer, we might differentiate between writing normal output to the user and writing error output to the user, even if, depending on your terminal, it may not look any different. Some terminals show it up in red, I think, and in Java, it's system.err instead of system.out. Same thing. All right, so we'll write a little error message out here if something bad goes down. And we'll also, because we promised it, although this is an interesting difference between Java and C++. Just because we promised we returned a string, we're going to return a string, it's not going to enforce that. We can choose not to. Modern day C++ compilers might give us a warning. In fact, I'm interested. A warning saying this guy didn't return it?
Yeah, and this is like right here, we want me to put a return statement on line 52, like after everything, if it somehow didn't get to you. Actually, you might just need to put it.
Well, the reason it's doing that is because there's no guarantee you get in here. Yeah, so you'll still get the warning you want it. It wants it after this somewhere. But warnings will still give you an executable, but I'd still take them seriously. Unless you just know like, oh, I expected that warning, it's fine. I'm using an older version of a library or something because that's what I'm supposed to do here. We'll just let it scream. So we'll just return the empty string there if there's no contents. Or if we really want to, maybe we can say no contents. Something like that. Okay, so that's what get contents will do. It'll go through, it'll open up the URL that's associated with the URL that we read in our constructor. It'll go do the stuff and ultimately spit out either the contents it found or just the string that says no contents. So let's go out to, I'm lost, where's my main driver? All right, I'm going to, well, actually, we'll just use this guy. All right, so we're going to go ahead and we're going to include URL.hpp. And we'll go ahead and create a URL pointer called U1 is equal to a new URL, passing it that string. And then we'll do a cout U1 get contents. And that should give us our output. All right, so let's go test this guy. I'm going to go ahead and update my compile, because actually what we want to compile right now is we don't want to compile curl test. Curl test is really a thing of the past right now because we've moved that data into something else. We'll probably even delete it here in a few minutes. But for right now, we want to compile driver and we want to compile URL. I'm finding something interesting here. Oh, there's my URL. Okay. So it's going to be driver.cpp and url.cpp. We're going to end up adding card in there as well, but let's just keep it one step at a time because we are going to modify card. We still do need to link the curl library because our URL is using that curl library. Oh yeah. In fact, that's what you probably would do. This just makes life a little easier. Whenever you want to compile, you just update this, and then I just do /compile, and it compiled it. So now if I do a.out, well, I got no, am I hooked into the internet? I got an error number 3.
Oh, I got that so many times yesterday. Error number 3 was overwhelmingly the most popular one that I got.
I wonder why.
For me, it was because my understanding at least was that you're passing it. My understanding is limited, but my understanding was that you're passing it like a string, like char pointer, RG.
Yeah. So it wants this guy as a standard string, not a. It wants it as a.
I changed it to a char pointer
inside of the URL. Yeah, let me, and that will work. That's when you deal with these older libraries that are expecting char pointers and they don't know about, I'm just gonna move this guy up here. They don't know about this. So if you go and look at our curl test, oh, we did fill up contents with this.
It seemed like it was because when it seemed like the command line argument.
Right, yeah, it was this guy here is expecting a char pointer. So I actually think what we can do is we can go in here. I think this will work. And our command line argument, the equivalent of that is this guy. I'm going to just try typecasting that to a char pointer. Because ultimately a string under the hood is a char pointer. That's what it is. So I'm going to say, look, treat this guy as a char pointer. Let's see if we can get away with that. So compile, yeah, see, it didn't like that. Invalid typecast. Let me look something up here real quick. C++ string to char pointer. Otherwise, we'll just make it work. Dot C string. That guy. So there's our stuff. This is effectively what this does right here is it takes this new style string and turns it into an old style string. It's what I was trying to do when I said typecast this to char pointer. Didn't like that. It's what you did do when you said, look, I just won't even screw with regular strings. I'll just use an old school string to begin with. Pick your poison. As a modern day programmer, we're gonna find it more friendly to use the C++ modern day strings. So this is kind of like a getter. We're saying take this string, call the string class must have a function in it. And let's see if I hover over this, will it give me some information about that guy? Returns the constant pointer to a null terminated contents. So this guy gives you an old school char pointer for a string. What it means by null terminated is that \0 guy that ends the string. Go ahead.
Is that a part of the include string?
Yes. Yep. Yeah. So this function is something it's an instance method, right? And it's an instance method, which means we call it using the instance of the class in which it was defined. This guy is an instance of the string class, which is defined inside of, well, it's actually inside of standard. It's where string lives. You actually did not need to bring in string.
I think I always have it in
Yeah, but I actually don't think it's needed here. So I think it's now part of standard. Let's try it real quick so I don't lie to you. Yeah. You definitely would have had to include string before, but actually I think that was for another string type. So you have, as far as I'm aware, you have 3 C++ string types that have existed. You have old school strings, which are just char pointers. Then you had something called a C string, which is part of something called the standard template library. If you've looked at any C++ programs and you see somewhere up top where it says using STL, that's the standard template library. So that was something that a collection of people built, probably an open source project, and says, hey, here's a whole bunch of crap that wasn't built into C++ that you might find pretty handy. We don't need that in Java because they probably added that stuff to the Java language to begin with, right? So that standard template library was kind of the precursor. Now we're dealing with, what is it, C++ 99, I think is actually there's probably a 2011. Yeah, there's a C++ 2011, I think is the current version of it. So you imagine that they said, hey, let's go ahead and pull some of that stuff into the standard C++ library. So that's the scoop. So however you want to ultimately accomplish it, I mean, what you did is you said, I need it as a char pointer one way or another. I did the same thing. I needed it as a char pointer. You just, how you got your char pointer just ended up being different, right? But this will be a nice convenient thing that probably everybody wants to make note of, because we're probably going to run into other situations where we as humans like using the new style string, but it's actually wanting some library we're using wants us to pass it an old style string, and we have a nice little helper function that comes with the string class that will do that for us. Go ahead.
So in the handle data function, that doesn't have to have everything in it that has in it right now, right? Like it doesn't.
I don't know. I didn't look at it.
That's like all of the stuff in there is not what handle data is. Handle data is just something that takes in those parameters.
Correct.
Has things in it.
Yeah. We can do whatever we want in handle data. We could just say hello world if we want and not actually collect the data from the stream. Like nothing says we have to collect the data. You probably want to. This is kind of why it exists, but you don't have to. Right. So what he's saying here is, did you have to write this stuff like just like that? No. You can put in there whatever you want. It's expecting you to return the number of bytes it read in, but heck, as long as you just give it a number, it's fine. Just return a 0. I didn't even check how many bytes you sent me. I didn't look at it. I just printed out hello world and moved on with life. All right. So I think, does that meet our requirements for the homework assignment? We're good with that? Okie dokie. So I'm going to clean things up here a little bit. I'm going to go ahead and I'm going to remove curl test. I'm also going to, well, we'll leave that alone. We'll go ahead and let's push. All right, so same thing. Make life a little easier, throw stuff into scripts when you need something to be automated. I type it in by hand the first couple times just to make sure you're kind of getting used to the cadence of Unix command line tools. But once that starts annoying you, throw it in the script and move on with life.
Did you open up the again?
No. That was real. It's up on GitHub too. Yeah, all those things. But yeah, this is, communication with GitHub. I'm just getting rid of the executable. I don't need to store that in GitHub. I'm adding everything to the local repository. I'm committing it with this message to the local repository, and then I'm pushing it to GitHub.
So that dot or git add dot, the dot is the same as the star.
Yep. Yeah. My guess is it probably does mean something different. There's probably a slight difference between them, but I'm not sure what it is. Maybe the dot only adds files of a certain category, where star adds everything. Yeah, I'm not sure. I can't go on without looking. Let's see. Let's see.
It's the kind of question where I don't even know what to look up.
Yeah, I'm gonna associate it with add. So dot versus star versus Batman. Like why? See, look, I got an answer. It's like, why did he put Batman in there? We'll expand to the current directory, whereas git star triggers file globbing.
Boy, I'm glad I didn't put that on.
Triggers file globbing and such expands to all files and directories that do not start with a dot. Let me see if they give a little deeper explanation of that. Because the way I'm understanding that, you actually would want to use the star. Oh. The difference here is if you use the dot, it gives you everything in the directory, but not those hidden files. So it's not also pushing your repository up there. Up there is a repository, right? It is a repository that's managed by your local repository. But if we go out here to our terminal, we don't see it usually. But if I do an ls-a, notice we have this hidden folder in here called .git.
Can you push .git up to GitHub?
Exactly, you can. That's just a folder because it's not executing up there, right? It's just a folder that would live up there. But we would say, hey, that doesn't really make sense to put that up there because this is controlling it locally. And then what gets put up there is the stuff, not the repository itself, because that's a copy of the repository. So that seems to be the difference, is that dot puts everything but those things, although it is kind of funny how dot puts everything except the dots, where star puts everything. I'm going to call that about a C- explanation. I'm not like super happy with the details of that, but
If I do git add star, would that put dot git up into the?
I believe so.
Okay.
Well, let's test it real quick. It's not going to hurt anything. VI push. Yeah, so you notice one thing changed. So let's go to my.
Hey, what did you do to not have to put your username and password in every time?
I did have to put it in a few minutes ago.
Yeah, so
Oh.
This isn't the repository. Repositories. Wouldn't it be nice if it just gave you the one you, it does. Does it always just give you the one you've updated most recently here?
That would make sense.
Yeah. Yeah, see, I don't see .git there unless this doesn't show you hidden files. Yeah. I'm going to stick with I'm not necessarily sure the difference. I think, I mean, we could probably sit there for 20 or 30 minutes and experiment with it and probably get a pretty good answer. So if you want to do that, you can get your 11 out of 10.
one out of 100.
That's right. All right. So what's our next step? So now when I run this guy, let's just compile it again real quick and see it run. We get our output, and our output here is in JSON format. Okay. Now, JSON kind of worked like dictionary. It's like a hybrid between a dictionary and a list in Python. So JSON format, in JSON, everything is something called a JSON object. The top level thing is a JSON object. JSON objects come in two flavors. They come in the flavor of JSON array and the flavor of, I'm going to call it JSON pairs. That's the dictionary looking thing, curly braces, name value pairs, where values, so this guy is boom, name value pairs, delim by comma, denim, delimited by commas. Is that how you do it? Delimited by commas. Where value is any JSON, any, let's call it any valid JSON type, including JSON objects. So you can have an int type, you can have a string type, so you can say name is equal to Mike. You can say age is equal to 5. But you can also say birthday is equal to curly braces, month is this, day is this, year is this. So you can give it a JSON object as the value. So you could have objects, inside of arrays, inside of yada, yada, yada. All right. So if we go out here and we look at our outputted code here a little bit, I'm going to pipe this to more. That shows me the beginning of it. So notice here, this thing starts off with a square bracket. So what it's giving me here is a collection. The top level JSON object here is an array. The type of JSON object is a JSON array. So it's giving me a collection of JSON objects. So the first object is that guy. The second object, I'm going to just make a guess here because I'm a little bit tough to read this, is that guy, so on and so forth. But notice in the second one that the play requirements, the value is actually a JSON object. So we have name value pair. So artist, then the person's name, card class, mage, collectible, true. So there's a Boolean type. Cost 5, there's a numeric type, another numeric type, string type for the value, string type for the value. And then for play requirements, the value type is JSON object. And this particular JSON object has 2 name value pairs. So require minion target is 0, which is probably false. Require target to play is also 0, which means false. I'm not sure why they didn't just use trues and falses, but they didn't. Whatever. All right. So we kind of understand the format of JSON, how it's working. So what we ultimately want to do, because again, we're focused on data structures in here, is we want to build a data structure that will go through this gigantic string and parse it into a single JSON object, which internally might have other JSON objects, so we can walk this collection of JSON objects. So that means we're going to have to write a parser. We're going to create a JSON parser. So JSON parser walks through a JSON formatted string and turns it into a single JSON object, which might contain other JSON objects or collections. So a single JSON object could be just a bunch of name value pairs. A single JSON object could actually be a collection of JSON objects. A single JSON object could just be a collection of JSON values, just a bunch of numbers like in a normal array. Okay, we're probably not actually going to deal with that type, just to keep it relatively simple for us. But we want to think about how, when we walk through something, how do we dictate or how do we parse this guy? So if we have JSON that starts off, let's say in our case here, we have a collection type. And inside here, we have an object followed by another object. I feel like I'm creating one of those, like this is like the beginning of like a face and ASCII art. Like I'm making ASCII art here. Oh, that was actually kind of, I don't know what that is, but it's awesome. Is that better? I don't think it's better. Right. It's an owl? That's what I was going for.
If you put the hyphen in both dictionaries,
That's an owl? Oh, it is. Oh, yeah. Give him a little beak. But you need it closer. We spent 45 minutes making ASCII. we tried to stop Lippman, but it was like we were trying to take away his toys. Somebody tried to distract him with Play-Doh. It worked for a second, but then no, not so much. All right, so let's just say we have like name 1 colon val 1, name 2 val 2. It's just gone. Took a BB to the eye. All right, so there's one object and here's another object. So we're going to make it slightly complex, but not like crazy complex, but hopefully we see the pattern in this. So now we'll have another one. So this will be name 1 we'll call this guy val3, name2, val4, something like that. Because that's like, this would be like first name and last name, first name and last name. Yeah. So maybe this is a bad example. I just, whenever I try to type in F name, it tries to correct me. See? Something like that. All right, because we're holding this. These are two separate JSON objects that probably contain the same kind of information, but different actual values. All right, so we want to write a parser that goes through this. So when we think about a parser, we're typically thinking about walking from the beginning of a string towards the end of a string, making decisions along the way. All right, so now if I start the beginning and the character I'm looking at is an opening square bracket, what does that mean that I'm dealing with here? It's a JSON array, right? So if I'm collecting a JSON array, if I am dealing with an array, what do I want to do? So at the high level here, if I found an opening square bracket, that means I'm dealing with a collection of stuff. What do I want to process here? If I'm going to process this array, ultimately, I probably want to create an instance of a JSON array, right? And I want to process this array. What is the string that is associated with the value of this JSON array? What's the string that is the value of this JSON array? It's everything in there, right? So how would I go about finding everything that's in there? If I found an opening square bracket, I want to find the corresponding closing square bracket. Nothing keeps us from having other square brackets inside of here. You can have collections inside of collections. So I need to actually find the closing square bracket for this guy. Make sense? So in this case, I hit an opening square bracket. So I'm going to jump forward one line and I'm going to start collecting characters until I hit the corresponding closing square bracket. So what question am I asking? I'm saying, is this a closing square bracket? Is this a closing square bracket? Is this a closing square bracket? So on and so forth, right? As soon as I hit something that is a closing square bracket, I know that everything up to, but not including this thing, belongs to that collection. Go ahead.
So to figure out, like, if it's collections and collections, to figure that out, we can check to see if there's something after that.
Okay, so let's add to this a little bit. Let's just say nums. We're going to say sums is 1, 2, 3. And we'll say, not that this guy has to have sums. In fact, we just leave it with one guy that has sums. All right, so the question is, if I have a collection inside of here, how do I actually determine where the corresponding closing square bracket is? I'm emphasizing that corresponding. As a human being, I can look at this and I can glance through this and say, oh, the corresponding one is here at the end because these guys are kind of self-contained, right? But the question is what's the algorithm to do that? Anybody have a, okay, go ahead.
I'm sure there's a simpler way to do it, but you could like have a counter that starts at 0, and then when you hit an opening square bracket, you can up by 1, and you hit a closing square bracket that's down by 1. And then whatever number that started at, once you find a closing square bracket, that's the same.
So whenever we hit an opening square bracket, we increment a counter. Start off at 0, so now I'm at a 1. Still at a 1, 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 still. Now I'm at a 2. Still at a 2, still at a 2. Ah, closing square bracket. Now I'm back to a 1. I decrement. I say, this is not the corresponding one because I'm not at a 0. Keep going, keep going, keep going. Hit another closing one. Now I'm at a 0. This must be the corresponding one. But you're not going to process those yet. We're solving this one problem at a time. The problem is I found an opening square bracket. I want to now get all the stuff associated with this collection. Once I process the inside of that collection, then I'll be dealing with a more local collection in there. Okay? So, yeah, I'm going to leave it like that for right now. We're going to have a little bit of an intermediate program here. So out here in driver, I'm going to go ahead and I'm going to comment out our URL for right now. And we're going to say a string, JSON string is equal, it's going to be, it's kind of sucky. That's okay. I want us to be able to focus on, in fact, I'm going to cheat. Eclipse fixes the string for you. I'm just going to use Eclipse real quick to go put backslashes in. Oh, but it doesn't really. All right, let's see if Visual Studio Code. We're going to spend all this time doing this. So it's I'm going to highlight this. Actually, I'm just going to copy this. That'll work. Oh, wrong button. And I'll do a find. I'm looking for the type of value I just searched for. Can I do a replace? Replace with a backslash, one of those. It's just going to take too much time. I'm just going to copy that. Anytime inside there I see one of those, I'm just going to doctor up my code. Ultimately, this is going to be a problem because they're reading it from that website. I'm just giving us kind of a sample thing to keep the assignment much more focused on what we're doing here instead of being, hey, we're processing wall of JSON initially. We'll get to that, but not initially. Well, I want it to be complex enough to for you to be able to write that algorithm that you described with the counting, because that's the correct algorithm, where it's a widely accepted algorithm. Let's just make sure I got that right. JSON string. Yep, so there's our output here. So let's go ahead and write out what the assignment's going to be, and then we'll talk about it for a few minutes. So homework, given the sample JSON string in the current code, start writing, well, actually what we can say is write a function that takes that string and returns a new string that has all of the contents of the top level collection. So if the string, example input of this would produce output of this. Note, don't just cut off the first and the last characters. Actually, well, because we don't know what it's going to look like. We want to be able to be nimble. Whenever we see an opening square bracket, we find the closing one. Whenever we see an opening curly brace, we find the closing one. So what it's going to look like in our code is it'll be opening square bracket, call process JSON array. Opening curly brace, call process JSON object. So you would actually process the JSON objects as you are going through, creating a collection. Instead of a string, you'll have a collection of JSON objects that ultimately are part of that JSON array. So we're starting off with just a string manipulation problem.
So we'll eventually have something that does like messes with a JSON array that when it finds like a JSON formatted thing that when it finds the square bracket, and then we'll have a function that has to do with the square bracket, and then we're gonna have something that says
Oh yeah, because what do you do if you see an opening curly brace? That's a JSON object. What do I do when I see JSON objects? Well, I process them. I process JSON object. Oh, that JSON object inside of it had a JSON array. What do I do when I see a JSON array? I process it. I call my process JSON array. So you're going to have like recursive calls, pseudo recursion, because you're actually calling a new version of process JSON array or process JSON object, but it's effectively a recursive call where you're saying, I'm in the middle of a JSON object, and now I found a value that's another JSON object. I'm in the middle of processing a JSON object, and what do I have to do? I have to go process another one in order to finish processing this one. Make sense? Okay, so this is just step number one of saying, look, I need to be able to find corresponding things, and it'll also get us some practice working with C++ strings. So don't just cut off the first and last characters. Actually walk through the string and write the algorithm to detect the corresponding closing square bracket to the opening square bracket. So for this assignment, you only need to deal with the top level parsing. We're just getting that practice of find an opening thing and find the corresponding closing thing. The stuff that's in the middle, we're just collecting as a string. We're not actually processing the stuff in the middle yet. All right, makes sense what I'm asking you to do? All right, questions, comments, concerns, bribes?
In C++, if you're having like a function that we can name into like driver.pd, for example, would you have to put that underneath using namespace and pd, or should it just I don't know if it matters.
It would need to be under, well, I don't think it actually matters if you put it before or after, but if you put it before, you can't use anything from standard namespace. That's logically correct what I just said, but since modern day compilers are two-pass compilers, technically you could use stuff from that, but I bet you at the very least get a warning. But good programming practice would be your includes and your using stuff should be at the very top. And the other stuff below that should be, and the old school way of doing this would have been to prototype these functions. I can actually show you an example of this, like the predecessor to header files. And it's really not any different. I think I can still do it inside this. Yeah, so see here inside of this C++ file, I got a bunch of includes here. Now, historically, what we're seeing is we would have probably had some, include something something .hpp inside a double quote saying it's in our local folder. But this is an old school library. So notice here at the very top, we're prototyping a bunch of functions. This is the stuff we would have found in a header file, right? That just says, look, compiler, you're going to run into some stuff below that is going to be used potentially before it was defined. Here's some stuff you might want to run into. Just trust me, it's going to be written. So this is the older way of doing it, by prototyping those functions rather than putting them in a separate header file. You can just.
Is this same thing like what people do with variables, and we do like number, and then you don't assign like a number to it? You just tell it like you will find this in there.
Well, no, because I mean what you're talking about is when somebody at the very top might say like int a, but not actually give it a value because they don't have a value for it yet. The intention is they're going to use it later on, something like that. That's not the same thing. A lot of times, first of all, I'm pretty suspicious when I see something like that, because on one hand, they might be trying to rely on what the default value is, which I'm not a fan of. I think if you want a variable to have a value in it, you put a value in it. That isn't to say that the default values can't be trusted, but I would just say good programming practice is to not trust it. Put a value in there. So I would never define a variable without putting a value in there, unless I was immediately going to start putting values into it. But even then, especially if you're dealing with an object type, I'll almost always start a variable off as the value. In C++, it's called nil. In Java, it's null. I'll say, look, this guy started off as nothingness. That is the default value for an object that doesn't have stuff in it. But I'll say it's equal to null. That way later on, I can say, hey, if something went wrong, is the value of this null? If it is, don't try to call functions on it, because then you get that whole null pointer exception stuff. Yeah, so I would just call that bad programming. That's not related to prototyping, because I mean, that's a true statement in any case. That's just variable scoping. If you have a variable that's defined somewhere, it's probably not defined at the top because they might run into it later on. It's defined before they use it because you have to define variables before you use them in a strongly typed language, which is why loosely typed languages can be frustrating, because they don't play by that rule. In a loosely typed language like Python, you're going to say, hey, I'm just going to pull this variable I out of nowhere. Or you thought you defined it above, but you didn't. But it still works. And it's just going to give you the default value for it, which I'm telling you not to trust anyways. All right, make some sense? All right, I will see everybody on, what day is today? So I'll see you Tuesday. All right, see everybody on Tuesday.